Spot's equation, Buckingham's equation, gear design for maximum power transmission, an introduction to AGMA code, American Gear Manufacturers Association. These are the things we will be discussing in spur gear, and then next is helical gear. So in helical gear, virtual number of teeth, force analysis, beam strength and wear strength, and effective load on gear tooth. So let us start with spur gear. What is a gear? Any toothed member designed to transmit motion to another one, or receive motion from it by means of successively engaging tooth is called toothed gear. Again, some another bookish definition is a multi-lobed cam or toothed wheel is also known as a gear. A gear is a toothed wheel with teeth cut on the periphery of a cylinder or a cone. The teeth of one gear meshes with the teeth of another gear, hence it is called a mesh drive or positive drive. It is preferred when medium or larger power is to be transmitted. You all are aware of another modes of transmission also. Chain drive is there, belt drive is there, and gear drive is there. Now we are discussing only about gear drives. Rotation of one gear will cause rotation of other in the opposite direction. If pinion is rotating in clockwise direction, gear will rotate in anti-clockwise direction, and vice versa will happen. What are the advantages or benefits of these gears? So gear offers some of the advantages as compact drive on account of small center distance. The small center distance, if you compare with the power transmission of the same capacity with chain drive or with belt drive, then definitely a very smaller distance is there. Then high efficiency, reliable service, and simple operation. It is a positive drive due to negligible slip between contacting surfaces. There is a slip, there will be slip occurring in case of belt drive. So here, very negligible, no slip occurring in gear drive. Then gear give higher speed ratio, and it can transmit very important higher power. Each drive has its own limitations. Chain drive, belt drive, gear drive. So gear drive is preferred for higher power transmitting capacity applications. It is possible to transmit power between parallel, non-parallel, intersecting and non-intersecting shafts. So what are the different conditions? We will see one by one. And power can be transmitted at higher loads. So this is again very important. Higher power is different, higher load is different. Limitations of gears. The error in the tooth meshing may cause undesirable vibration and noise during operation, though it is having significant advantages. But if it is not machined, not having the proper profile shape, then the error in the tooth, it will lead to undesirable vibration and noise. Costlier than belts and chain drives. Power cannot be transmitted over long distances. See, again, if you compare this with belt drive, the distance between two shafts and the distance between two shafts for gear application. Again, it is compact drive, but the power cannot be transmitted for longer distances. Precise alignment of shaft is required and require continuous lubrication. So these are the some points. Applications of gears. The gear drive has wide application in following fields. There are many fields. A highlight summary is mentioned here. Metal cutting machine tools. In all our machine tools, wherever we are observing every machine, there is a gear. Automobile, a very different types of gears are used in automobile for different applications. Tractors, then hoisting and transporting machinery, rolling mills, marine engines. So there are many applications where gear application is there. Classification of gears. The gears are classified as parallel shaft, intersecting shaft, and non-parallel non-intersecting shaft. Parallel shaft, spur gear, helical gear, double helical gear, herringbone gear. So spur gear, you know, you at least need some idea is with your spur gear, the teeth are cut parallel to the shaft. Helical gear, the teeth are cut at an angle which is called as helix angle to the axis of the shaft. Double helical gear, when two identical helical gears are attached together back to back or with opposite hand of helix. I will show you the figure also. It is the case of double helical and herringbone. Both are similar type gears. Then intersecting shaft. Bevel gear is there. When the power is required to be transmitted at intersecting shaft, straight bevel gear. Then spiral bevel gear, the teeth are cut at some curvature. Then gyral bevel gears and phase gears. Then non-parallel, non-intersecting shaft. Again here spiral gears is the case. Hypoid gears and worm gears. These are non-parallel, non-intersecting shaft application. So as the application or power transmission is required between two shafts, based on that particular application, the gear is selected. Number one. Number two, now for parallel shaft is there. Anyone can go for spur, anyone can go for helical, anyone can go for double helical. So each one is having its advantages and disadvantages. So for lighter application or less load transmitting capacity, spur gear is preferred. Some higher RPM is required, some more speed is required. In that case, helical gear is preferred with some higher capacity. And the helical gear, two helical gears are used. It forms double helical or herringbone gear. So much more higher power transmission at much higher RPM, and it can also tolerate somewhat you can say axial load is there. So it can tolerate some axial load. The bearings required because the axial load is getting nullified in case of double helical or herringbone gear. So these all things again will be discussed in the force analysis of this spur and helical gears. First spur gear. So you can see here the spur gear. So the teeth are cut parallel, and again this is one external gear and internal gear. The second figure is for internal gear and first is for external gear. The teeth are cut parallel to the shaft. So the smaller one is generally called as pinion and the larger one is called as the gear. So this is the gear pair. Okay, and the second one, it is teeth are cut on one of the case internal and other gear is external and they are matching. So depending upon the application, the gears are used. This is very first type spur gear. Helical gear. The left hand side figure, right hand helical gear and left hand helical gear. The teeth are cut at an angle which is called as helix angle to the axis of the shaft. You can see the second diagram, a 3D pictorial view is shown. So here you can see clear cut the teeth at particular some angle and the two teeth gears are matching. So for some higher power transmission capacity and higher load, helical gears are preferred over spur gears. Double helical or herringbone gears. You can observe here clearly the two helical gears. See, these are two gears as shown in figure. So two helical gears, when they will combine, then we can call it as double helical or herringbone gear. Now if you see, it is having the means double capacity of helical gear. So very high power transmission condition, rotating at some higher loads. So depending upon the application, only these gears are preferred. Straight bevel gears. Intersecting axis. If you take the axis of the pinion and gear, they will intersect, for example, for this case at 90 degree. This and teeth are cut straight. If you see the teeth are cut straight. And in the second case, spiral bevel gear. So in spiral bevel gear, the teeth are cut at some curve. So these are called as spiral bevel gear. Again, if you compare, if there is a comparison between straight bevel and spiral bevel, the same comparison will be between somewhat, I will say, between spur and helical gear. The straight bevel gears can transmit a lesser load and can rotate at some lesser RPM as compared to spiral bevel gear. So this is the advantage of spiral bevel gear. And if we consider the manufacturing aspect and design aspect, then definitely spiral bevel gears are costlier as compared to straight bevel gears. Gyral bevel gears. This is one type of bevel gear where the pinion and gear are of same size, module same, number of teeth same, and they are at an angle 90 degrees. So the angle between, if I take the intersection point, then both sides the angle will be 45, 45. If you say the last diagram, the straight bevel gear, if you see, pinion is smaller and gear is larger. So it is straight bevel gear. If you see here, both are same, pinion and gear having same dimension. Such a case is called as Girol bevel gear. Hypoid gear. You can see, you can observe here when I am saying non-parallel, non-intersecting. These are non-parallel. The gears are means last case also non-parallel. But in bevel gear, intersecting shafts are there. If you consider here the axis, it is non-intersecting. So offset is there. A hypoid gear is used when the included angle is square and distance between the axes are relatively small. The hypoid gear is viewed as intermediate between bevel gear and worm gear machine. So if such conditions are there, when the axes are having some offset, then one has to go for hypoid gears only. And in the second diagram, it is clear cut shown that the axes are non-parallel and non-intersecting. If you go for bevel gear, they are non-parallel, but they are intersecting. The axis of pinion and axis of crown, or you can say wheel or gear. But in case of these hypoid gears, the axes are non-parallel and non-intersecting. Worm gear. In any workshop for any machine, the worm gear is used where there is the very first application where there is a higher power or higher ratio is required. So this is worm and this is worm wheel. Again, non-parallel, non-intersecting case is there. This is worm and worm wheel case, and here one can go for 40:1 to 100:1 ratio also in case of only worm and worm wheel. Others are having ratio up to 6:1, 10:1 for power transmission gear ratio, but for worm and worm wheel the ratio can be up to 100:1. So a great power transmission is achieved in case of worm and worm wheel. But the disadvantage of this case is also, we can say here in generalized constraint, that last three gears whatever we have seen, there is, for not a single gear, it is required to consider the friction between the mating teeth, the heat generated due to the friction, and the heat dissipated, or we can say the coefficient of friction will be taken into account and its effect on the efficiency of the gear. So these all thermal related aspects due to heat generation are required to be taken into account in case of worm and worm wheel, as there is a more friction. This is rack and pinion arrangement. If you see simple or any lathe machine, then you can also observe this rack and pinion arrangement. So rack, a straight type gear where profile is there, and a pinion you can see. Then in this case, for the pinion, pitch circle diameter is shown, then circle diameter is shown. For rack also, pitch line is there. The pitch line and pitch circle diameter, they are matching, and that point is called as pitch point. The detailed terminology again we will be discussing. This is the linear pitch. So this is the introduction of different types of gears and small relevance of their application, where they are used and why they are used at that particular place. So this is just the introduction. Now let us go for somewhat brushing of knowledge as far as terminology of gear is concerned. So this is very first terminology. You can see a gear is shown, pitch circle diameter. Then the cursor is visible. So you can see here I am showing. So this is pitch circle diameter. Okay. Then the outer part is addendum circle diameter. The inner circle is dedendum circle, and base circle is also shown. So let us see one by one the terminology. So pitch circle. So in this case, the pitch circle, it is an imaginary circle which by pure rolling action would give the same motion as the actual gear. So the gear, when two gears or pinion and gear is in contact, then the contact occurs at only pitch point or pitch circle or pitch surface. And this, whatever the imaginary circle drawn, it is called as the pitch circle. Pitch circle diameter. Second point. It is the diameter of pitch circle. And very important next consideration, the size of gear or pinion is generally specified by pitch circle diameter. It is also known as pitch diameter. So, in design consideration, in industry, if you refer the drawing and design considerations, then there is one word mentioned, PCD. PCD 100, PCD 120. So it is nothing but a pitch circle diameter for that pinion or for that gear. So pitch circle diameter. Okay. Then pitch point. It is the common point of contact between two pitch circles. This is the imaginary point where two pitch circles are making contact. Pitch surface. It is the surface of rolling disc. If you imagine only two pitch circles in case of this teeth, then whatever the two surfaces rolling disc or two rolling discs are rotating in contact, then that particular surface is called as pitch surface. Pressure angle or angle of obliquity, very important concept. It is the angle between the common normal to two gear teeth at a point of contact and the common tangent. Now, see here, if I will draw a common tangent, assuming that upper side there is one gear, then this will be somewhat common tangent. Okay, just 1 minute. See, this is the common tangent. If you assume that on another side there is other gear, and then common normal, assume that here one more gear is there, then like this. This is a rough approximation, and whatever the angle is called as the pressure angle. Then moving to next. Addendum. This is the radial distance of a tooth from the pitch circle. So in this figure, if you say this is pitch circle, so pitch circle to addendum circle is called as the addendum. So here it is shown, this distance is called as addendum, and pitch circle to dedendum circle is called as the dedendum. It is the radial distance of a tooth from the pitch circle to the bottom of tooth. So pitch circle is drawn, and pitch circle to top of tooth addendum, pitch circle to bottom of tooth dedendum. Addendum circle, it is the circle drawn through the top. It is circle drawn to the top of the teeth, and it is concentric to pitch circle. It is called an addendum circle. And dedendum circle, it is the circle drawn through, see, bottom. I am showing through arrow here, bottom side. So it is called as root circle also. Circular pitch. It is the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point of next tooth. This is generalized definition of any pitch, distance between two consecutive points. So here the distance is required to be measured along the pitch circle. So if I will take this point and next gear I will take this point. So distance between these 2 points I will call it as a circular pitch. Or here another example is mentioned, distance between these 2 points. This is first point and this is second point. The same point on one point on first gear and the same point on another gear. So this you call it as a circular pitch. So this point I have marked as first point, and the same point on another case I have marked as second, and whatever this distance is shown as the circular pitch. Circular pitch is given by d by t, where d is the pitch circle diameter or diameter of pitch circle divided by total number of teeth. So it is very basic that for good meshing, the two wheels should have the same circular pitch. One gear is having some pitch 100 or example 50 mm and another gear is having pitch 40 mm, then there will be no meshing at all. So this pitch circle should be same or circular pitch should be same so that there will be good meshing. Diametral pitch, it is the ratio of number of teeth to pitch circle diameter. Diametral pitch, number of teeth divided by pitch circle diameter. PD is equal to T by D. Number of teeth divided by pitch circle diameter. There is one more concept which is opposite to diametral pitch. So it is the next concept, module. It is the ratio of pitch circle diameter in millimeters to the number of teeth. It is D by T. So module is D by T and diametral pitch is T by T. So I will say that module is equal to 1 upon diametral pitch or diametral pitch is equal to 1 upon module. So module, it is the ratio of pitch circle diameter in millimeters to the number of teeth. Pitch circle diameter D, number of teeth T, then module is given by D by T. Module is given by D by T. Clearance, it is the radial distance from the top of the tooth to the bottom of the tooth in meshing gear. See, this is the clearance or working depth. So if another gear, assume that this is the pinion and the gear is coming up to this point. So this is the clearance, bottom of the tooth and other side top of the tooth. So this is clearance. The circle passing through top of the meshing gear is also known as clearance circle. Total depth, it is the radial distance between addendum and dedendum. So if I want to calculate the total depth, then I will go for just addition of addendum and dedendum. So this is, you can say here, this is addendum and dedendum. So this will give you the total depth from this point up to this point highlighted in the figure. So this is the total depth for a gear. Working depth, it is the radial distance from addendum circle to the clearance circle. Working depth, it is the radial distance from addendum circle to the clearance circle. Addendum circle top side and clearance circle this bottom side. So it is the sum of addendum of the two meshing gears. It is the sum of addendum of the two meshing gears. Total thickness, it is the width of tooth measured at pitch circle diameter. Very important. Thickness, it is nothing but the width of the tooth, but very important, measured at pitch circle. So from pitch circle, I will highlight here from this point to this point I have highlighted. So whatever is there, it is called as the tooth thickness. Tooth spacing, the width, tooth spacing, it is the width of space between the two adjacent teeth measured along the pitch circle. See here now, what is the spacing available, width of space. For example, now I will highlight this point to this point. So this is the tooth space highlighted in the figure. Once again, I am highlighting the same. So this is the tooth space. Again, it is should be measured along the pitch circle only. Backlash, very important concept in gear terminology. It is the difference between the tooth space and tooth thickness. Very important. It is the difference between the tooth thickness and tooth space, whatever in between space is available and whatever the thickness of the tooth. Measured along the pitch circle. It is very important. It should be measured along pitch circle. Theoretically, the backlash should be 0. See what is mentioned. Theoretically, the backlash should be 0, but in actual practice, some backlash must be allowed. So if you see why the backlash is required, there are different reasons. If no backlash is there, then the gear will not function smoothly. So the backlash is purposefully provided in a gear in order to avoid the jamming. If the backlash is 0, then there will be definitely jamming of the gears and it will not function smoothly. Then in order to accommodate the error of the tooth, the error may be produced due to the manufacturing process. See, there is no any process. If you go for grinding also, super finishing process, gear grinding, then in that case also some tolerances are given. Why? Because it is not possible, or I will say rather than feasible, to provide or to fabricate, to manufacture a gear with exact dimension. Therefore, there is mentioned, for example, tooth thickness is required, then it is mentioned 30 mm, 30 millimeter plus minus 0.5 plus minus 0.3 millimeter. So this is, if it is not plus minus 0.3 or whatever allowance is there, it is compensated by the backlash. So whatever error will be there, it is compensated by the backlash. And third very important point, thermal expansion. There are many cases where the gear will be operated at higher temperature. In such cases, there will be thermal expansion of the gear. And if there will be thermal expansion, the size of the tooth will be increased by some, let us assume that 0.5 millimeters. If there is no backlash provided, then that 0.5 millimeter, how to accommodate? Definitely there will be jamming. When it will come at room temperature, again there will be contraction. In order to encounter, tackle such thermal expansion issues, backlash is provided depending upon material, depending upon expansion properties, thermal coefficient, and depending upon the application where it is utilized, where the gear is mounted. For example, I will give you nuclear power plant application. So nuclear environment is there, and if the gear is operated at continuously 400 or 500 degrees Celsius, definitely there will be expansion occur, and due to this expansion, the size will be vary by some, and if the size of the both gears will be increased, let us assume by 0.3 millimeter, 0.3 millimeter, then 0.6 millimeter tooth thickness will be increased. How to accommodate, how to compensate the 0.6 millimeter? So in order to compensate to this 0.6 millimeter and avoid further jamming and failure and of this particular gearbox, backlash is purposefully provided. This is very important concept, backlash. Face of tooth. It is the surface of the gear tooth above the pitch surface. So here it is shown. So this is the face of tooth above the pitch surface, and flank of tooth. It is the surface of the gear tooth below the pitch surface. It is shown here below the pitch surface, flank of tooth. Top land. It is the surface of the top of the gear tooth. So here it is shown the top of the gear tooth. I am highlighting it is top land. Face width. It is the width of gear tooth measured parallel to axis. Very important. Measured parallel to axis. Once again, I am highlighting. So this is the face width. Face width is one of the important parameter in gear calculation for all types of gears. Profile. It is the curve formed by the face and flank. So this is face and flank. I will try to highlight. So this is the profile, whatever generated, whatever you are observing here, this is the profile. Fillet radius. It is the radius that connects the root circle and the profile. See here. This is the root circle and this is the profile. So there are no sharp corner. A small radius is provided here. See, a small radius is provided here. This radius is called as fillet radius. So this is the generalized gear terminology which is required, very essential for understanding the gear design. We will be using different terms like addendum circle diameter, dedendum circle diameter, pitch circle, then circular pitch, then face width, module in different calculations, pressure angle. Therefore, the understanding of the basic part, that is the theory, the basic nomenclature of the gear is required, which is just now we have discussed. Now this is the standard system of gear tooth. There are different standard system of gear tooth, but before moving to standard system, I will explain the concept of basic rack. What is basic rack? So whatever is explained, everything, these all things are explained with the help of this shape shown, basic rack. So what is this basic rack? If I increase size of any circle, for example 100 millimeter, 1000, 1 lakh millimeter, let us say 1 kilometer, 100 kilometers, 1000 kilometers. If the circle is of 100 millimeter, if I take a certain portion, there is a small curvature. If the circle is of 1000 kilometer, if I take a small part, it is a straight line only because the diameter goes on increasing and increasing, increasing and increasing. Then the curvature becomes straight line, straight line. If I view from somewhat other side or somewhat higher distance, definitely it will look as a circle. But if I take a certain part, I will try to highlight here to assume that take any. So if I consider this part to this part, I will call it as this between a small curvature. But if the same thing, a larger like circle is there, and if I take this part to this part, I will call it as a straight line. And again, there is a limitation, whatever I am showing. If you assume that this circle is of 1000 kilometer radius, 5000 kilometer radius, 10,000 kilometer radius, infinite diameter, then the circle, whatever certain portion we are selecting, then it is becoming straight. The same thing is happening if a gear is manufactured for such case. The shape will not look like this. The shape will look like a straight lines for the profile, and this is called as the basic rack. So this is the concept of basic rack, and based on this basic rack concept, the further three things are three systems we will be understanding or we will discuss based on this basic rack. So first one is 14.5 degree full depth involute system. So the basic rack for this system is composed of straight sides except the fillet arch. Now see here, this is the pitch line shown. I am highlighting. This is the pitch line shown. Up to addendum, it is 1.157 module. For addendum, it is just module. These are the standard considerations. For pitch, for thickness of the tooth thickness, it is 1.57 5708 times module, and for tooth space, it is again 1.5708 times module. The pressure angle is shown here 14.5 degree. This is one of the system. This is a standard system. We have to select only system. These all things whatever shown in the diagram are standard. So interference occur when the number of teeth on the pinion is less than 23. Now before going to this particular sentence, what is interference and what is undercutting? So interference occurs when the top side of one of the gear will dig into the bottom side or root side of the other gear, and the material starts removing. So this is the interference. And when this happens, when there is a certain, we can say, less minimum number of teeth required for any type of gear. So if we are maintaining or fabricating a gear lesser than that, means for example a pinion for any typical system, the gear require minimum number of teeth required 23. So for this system, if I fabricate a gear with 10 tooth or 10 teeth on pinion, definitely there will be interference occurs. This system satisfactory is satisfactory when the teeth on the gear is large. If the number of teeth is small, and if the gear is made by generating process, undercutting is unavoidable. So these are the basic things. Now let us move to next system. Then you will come to know what we are discussing about this parameters. So next system is 20 degree full depth. We have already discussed what is basic rack. So here just try to compare the distance. Last slide 1.157 module and this gear 1.25 times module and module. So it is whatever the total height if we say, or whatever the dedendum shown, the dedendum is smaller as compared to 14.5 degree. Why this happens? Because this angle becomes 20 degree. In last case the angle is 14.5 degree. There is no change as far as this tooth space and tooth thickness is concerned. The minimum number of teeth required for this case, theoretically I am this last case, the theoretical number of teeth 23, for this case theoretical number of teeth 17. The pressure angle 20 degree, therefore it is called as, it is highly recommended system by Indian Standard, Bureau of Indian Standard. Again we will be discussing what are the advantages of this system over last system. Increasing the pressure angle improves the tooth strength but shortens the duration of contact. How the tooth strength is increased? See here, I will explain. This is angle is 14.5 degree. The angle is 14.5 degree. So whatever the base will be there, whatever the thickness or whatever this base will be there, and now I compare for another case, the angle is 20 degree. So somewhat more inclination in this side as compared to 14.5. If I will take 14.5, it will come something like this, and it will like this. So this is the line for 14.5 and this is the line for 20. So the teeth become broader. The teeth become broader at the base, and due to this broader teeth, definitely we can say increasing pressure angle improves the tooth strength but shortens the duration of contact. Shortens the duration of contact. Decreasing pressure angle requires more number of teeth on pinion to avoid undercutting. This I have already explained. As we decrease the pressure angle, more number of teeth are required. For 14.5 degree, 23 teeth are required. For 20-degree system, 17 teeth are required theoretically. 20-degree pressure angle is a good compromise for most of the power transmission as well as precision gearboxes. So the teeth are become stronger, so good for power transmission and precision gearboxes. There are different advantages of 20-degree pressure angle system. So it reduces risk of undercutting. Again, we can say this is 14.5 degree system. So here also the angle will be same 14.5 degree. And if you see here, the teeth will become like this. So whatever the spacing, whatever the spacing we are getting, this is the additional space it will get so that no undercutting will be there. When the another teeth will come like this, so no undercutting will be there due to this additional space as compared to 14.5 degree full depth involute system. As no undercutting, less chances of interference. What is interference and what is undercutting? Just now we have explained interference when the one of the gear part, the top portion is digging. I am using the word digging, or it is interfering the bottom portion, root portion of another side. It is called as interference, and the removing the interfering part by using, for example, a rack type pinion by some machining is called as undercutting. So less chances of interference, less chances of undercutting. Due to increased pressure angle, the tooth becomes slightly broader at the root. This just now I have explained. Tooth becomes broader at the root, and if the tooth becomes broader, it will increase the load carrying capacity. It has greater length of contact. So these are the some of the advantages of 20-degree full depth involute system. Therefore, 20-degree full depth involute system is generally recommended for many of the applications, and it is also recommended by IS, Bureau of Indian Standards. And the main advantage of 14.5 pressure degree means quietness of operation. There is more noise generation in case of 20 degree as compared to 14.5 degree full depth involute system. Now next, let us go to next 20-degree stub involute system. 20-degree stub. So again the angle is 20 degree. So name is stub. If you compare for last two cases, one of the case it is 1.15, it is 1.25, and here it is only module. The dedendum is smaller. The last two cases, it is one time of module. For stub, it is 0.8 times of module, again smaller. So if you go for the total, it is smaller as compared to last two cases. This is standard, 20 degrees same. So the interfering portion of the tooth, that is the part of addendum, is thus removed. The teeth is smaller. Therefore, the interfering portion is removed. Therefore, smaller interference and no undercutting or reduces the chances of undercutting. Minimum number of teeth required are 14. 14 for very first case, 14 point full depth involute system, 23 teeth are required. 20-degree full depth involute system, 17 teeth are required, and for this case, 14 teeth are required. And see here, overall dimensions are smaller. The drive or the tooth becomes smaller, the gear pinion becomes small, and the drive becomes compact in nature. Again, the stub teeth are stronger than full depth also. Now see, both the cases angle 20 degree. But if you take 1.25 plus m. So it is 2.25 times module. And it is m plus 0.8. It is 1.8 times of module. As the length is same or length is lesser, smaller moment arm of bending forces. So this is stronger at the base and the length is same. So smaller moment arm will be there and therefore it can transmit higher loads. It results in lower production cost. Again, due to this factor, lesser costly. But the main drawback of this type of system is due to the short addendum. There are chances of overlap and vibrations are likely to occur in case of this 20-degree stub involute system. See here, the drawback of this system is the contact ratio is reduced due to short addendum. So the addendum is short, contact ratio is reduced, and due to insufficient overlap, vibrations are likely to occur. So these are the disadvantage. This is the disadvantage of this system. So three different systems we have discussed. These are very important for all four types of cases. We have discussed basic rack, the definition. Then first system is 14.5 degree full depth involute system. See here the addendum and the dedendum. Then 20-degree full depth involute system, addendum and dedendum. Advantages of 20-degree system over 14.5-degree pressure angle system. These are the advantages. Less chances of interference, undercutting, increased pressure angle, tooth becomes slightly broader. Therefore, load carrying capacity is higher. The only advantage of 14.5-degree full depth system is quietness in operation. They are quiet in operation. And last, very less used 20-degree stub. Wherever there is a compact drive is required. Smaller dimensions are there where we have to opt for that particular drive. In such case, only 20-degree stub involved system is preferred. If you add these two, it will become addendum plus dedendum 1.8 times of module. Short arm is there and the teeth are stronger. Next point is design considerations. So there are, if any gearbox we have to design, then very first part to be taken into account is the design considerations. These are the basic things required for design of any of the gear. So very first part, this is very important thing. Very first part of power to be transmitted. How to design a gear? You should know, anybody should know the power to be transmitted. Design a gear pair to transmit 35 kilowatt, 10 kilowatt, 5 kilowatt, 1 kilowatt. So very first consideration is power to be transmitted. Then second thing required, speed of the driving gear and speed of the driven gear, or you can call it as velocity ratio. This defines the stages of the gear. For example, power to be transmitted, assume that I want to transmit 10 kilowatt of power. Okay, then speed of the driving gear, assume that standard case I will take 1440 rpm. Now velocity ratio or speed of driven gear. If I will say that speed of driven gear is 360, then 4:1 ratio reduction type, very simple spur gear can be used for this application. Now if you take this 10 kilowatt as it is, this 1440 as it is, but instead of 360 rpm, if the speed of driven gear, assume that it is only, let us assume that 18. So 1440 to 18, if you divide, the ratio is much more higher. So what is required to be done in such case? In such case, any designer has to go for multi-stage, 2-stage, 3-stage, because in a standard case, the maximum transmission allowed for spur gear is 6:1. So here 1440 divided by 6, up to that only I can transmit. If I divide 1440 by 6, it will not 18. It is much more than that. Therefore, I have to go for some higher, means multi-stage design I have to go. And very important is center distance. What is the required center distance in which I have to transmit the power? So these are the very basic things required in design. So power to be transmitted, very important. These are the essentials for design of any gearbox. Then speed of driving gear, uh, input gear, speed of driven gear, or velocity ratio also we can call it as, and center distance. The center distance may be in centimeter, millimeter. So depending upon these four, the type of the gear to be selected, the material to be selected, the atmosphere, the specific application in which it is used, the all other things will be come afterwards. So if you know basically these four things, then we can go for design of a spur gearbox, design of a gearbox with helical gears. So these are the important 4 points or design considerations for design of a spur gear or any type of gear. Now, there is one mini project. If you refer to the particular numericals, then in that numericals, apart from this, the face width, the module, and other things may be given, and it is required to calculate the power and other thing, beam strength, wear strength, or if the strength is given, it is required to calculate the module. So apart from these four, many things will be given. So based on these four basic, we will be designing a spur gearbox by taking these four only and assuming all the data, taking the data from design data book, using the design data book, selecting the material from design data book, and we will proceed further. So these are the design considerations required for a gearbox.